All right, here's the Gold Rainbow Review. The Gold Rainbow Review covers the section 10.3 from Pearson or a textbook. And this section had a lot of different things in it, end behavior, domain range, interval notation. It also included some things about axis of symmetry, minimum values, etc. So there was a lot in this section. So let's start with the end behavior. This shows up in a couple different problems on this review sheet. End behavior is talking about what happens to the graph as it goes as far to the right as possible or as far to the left as possible. So when I say as x is approaching infinity or as x is getting to infinity, that's actually saying, okay, as this graph goes to the right, what is happening? And when I say as x is going to negative infinity, that is really saying to the left. All right, so we're talking about what happens to the graph on the right and the left. And what I usually do to imagine this is I picture like a person walking. So if I'm looking at this graph, and let's go to the left first, since I think that's a little easier to see. If I'm going to the left, this graph is going in what direction? It is going up, right? It's going left, but it's also going up. It's never going to stop going up either. So the way that we represent that is we say it is going to infinity. Now, if it was going down, we would say negative infinity. Okay, up is positive infinity. This is an exponential curve, and these are one of the harder curves to do and behavior with because it's not going down on the other side, right? So if I'm going to the right, this curve is not actually going down. It is flattening out, and it's flattening out along that asymptote. So exponential functions are those special functions we learn that have that imaginary line that the graph gets close to. So these are going to be the ones that have a little bit different answer for end behavior. So as we're going to the right, we're not going down, we're actually getting really, really close to -3. Okay, so exponential functions are kind of special in that sense of that they are approaching a number, not necessarily infinity or negative infinity. Let's look at this parabola here. They gave us the equation, but they also gave us a graph. They want us to use interval notation for the domain. Now remember, domain are our x values. It's talking about what happens to the graph as we go to the right and to the left. Does it stop, right? Is it being forced like tight in between some boundary lines? And in fact, a parabola is not. A parabola is constantly getting wider. So if I could draw like for as long as possible, that graph is just going to keep getting wider and wider and wider. So it's going to go to positive infinity and negative infinity. Now, we talked about this in the pink rainbow review, but if you need a refresher, we need to decide really between A and B then. The difference is the types of brackets that they're using or grouping symbols. When you have the like the cornered one or the square ones, these represent that they could equal that. And when you have the curved one, it means they cannot equal. Well, something to know about infinity is you will never actually equal infinity. It's not really a number, it's a concept. It means it keeps going on and on and on forever. So whenever you are using an infinity, you will always use the curved brackets because it will never actually equal infinity. All right, let's talk about the range. Range are our y values. How far up, oops, how far up and how far down does this graph go? Well, one direction I think is pretty easy to see. If I were to try to like imagine stopping this parabola from going up, it doesn't stop, right? It keeps going up and 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 up. So it is going to positive infinity. If I think about, okay, how far down does this parabola go? Well, it doesn't go down forever, right? We hit like this bottom part and it's not passing -5. That is the smallest point or the minimum value. In fact, our vertex right here is at -1, -5, right? It's right on that point. So the lowest that our graph can go is -5. So to use interval notation, again, if I'm talking about infinity, it would be a curve because I can't equal it. So that's my highest value. My lowest value is -5, and the question is, can it equal -5? And in fact, it can because that is the vertex. So our answer here would be letter A. Axes of symmetry. This is something we've talked about with parabolas. The two graphs that are going to have axes with symmetry are going to be our parabolas and our v's, right? So which of the following graphs have graphs with axes of symmetry? Well, it's going to be our absolute value and our quadratic, right? Absolute value are v-shaped graphs, quadratics are our u-shaped graphs. A square root function does not have an axis of symmetry. Axis of symmetry, again, is like that imaginary line that divides our graph in half. That doesn't happen here. And then letter B is an exponential function, so it looks something like this. And again, there is not like that imaginary magical line that would cut that graph in half, so it doesn't exist. If you are feeling frustrated or confused on this, absolutely pull out Desmos or your graphing calculator and get a good picture of what these look like. Next, you have a picture of an absolute value graph. It asks some questions here. First off, what is the minimum value, the smallest, the lowest that this graph goes? So it's kind of like asking, what is that lowest part of the range? So the lowest part here, or the lowest value, would be at -3. The axis of symmetry is that imaginary line that splits our graph exactly in half. And what a lot of people are going to say is just 2, but an axis of symmetry is actually a line, so you need to write it as an equation. If you remember back to quadratics, we drilled this, that our axis of symmetry is always x equals the number. And then using interval notation, what is the domain and the range? This is very similar to the parabola that we did up above. So in order to save some time, I'm going to have you reference the problem above. Number 9 is talking about end behavior, very similar to the one we did before, but slightly different because this is a different curve. So again, as x goes to positive infinity, it's talking about, okay, as I go to the right. So if I started here, okay, we get this little hump, which is pretty cool, but I don't care. What I really want to know is where is that graph going if I go as far to the right as possible? And it is pointing down, so it's going to negative infinity. If I go to the left, okay, we get that cool little hump here, but again, doesn't really matter because what I care about is what is happening as I go the furthest to the left I possibly can, and my graph is going up. So we say to positive infinity. I hope that helped you guys. Let me know if you have more questions.